Okay, thank you to be here. Let me start now with the lecture of today. You can find the material here in my study. Yeah, we can see here under session 0,4. Yeah, we can see lecture 4. No? I reorganize a little bit the material in terms of sessions because each session contains more than one lecture. Okay, I will repeat very quickly a little bit what we did last time, then we will go ahead. Now the program basically, the program of the course is as follows. I will consider the parametric model. You remember I told you what the parametric model is. We will consider the structure of the parametric model at the beginning. Then I will move to the control. I will control the Lotka-Volterra equation or the equations. But nevertheless, I will reconsider do you remember that this easy model related to the bank system in order to introduce the concept of the dynamics. At the end, we will come back to the estimation of the parameter. This means we will assume that we know everything about the system. What intend for everything we will see also today. Because otherwise, if now we start with the parameters, we have seen a little bit the identification of non-parametric model. But of course, the identification of the parametric model is something nevertheless interesting and connected with what we did until now. But I think in order to do something different, I will insist on the dynamical systems, structure of the dynamical system, differential equations, parametric model, but without at the beginning consider the problem of identification of the parameter. This I will come back on this later. Otherwise, it could be that it's a little bit boring. This means I would like to insist on the differential equations a little bit using some simulations, this model of today, and then Lotka-Volterra, including control. And then at the end, we will come back on the parametric estimation. Okay, the lecture of last time now is in my study. Last time, I don't know if you remember, my study didn't work. The lesson looks like, the lecture, excuse me, looks like. So let me open the lecture. We can see the title a little bit strange, but as I told you, here in complementary course or the courses, we are trying, let me say, mixing different topics because the course is organized is, let me say, topic oriented. Or the topics oriented. This means we select some lecture for other courses in order to give us the possibility to choose different projects in accordance with your background. Yeah, this was a lecture included in MATLAB. I would like to show you MATLAB too a little bit. Simulink, because until now we have seen MATLAB, but not Simulink, right? No Simulink. Therefore, here MATLAB Simulink, they are connected. They are strictly connected. But here, basically, is a little bit Simulink. Really flesh out this. We have an example, the bank account system, extremely easy, but not so easy. We can see here in the middle, we have a sketch, the name, bank account system. We can see interesting, nevertheless, three arrows. Deposit. We can understand I put inside my account some money. If the deposit is negative, the arrow goes in the other direction, and this we called withdraw money. Positive input is deposit, negative input when I withdraw money. The arrow reflects exactly the intuition. But very often, as I told you, the intuition is not so visible in the scheme. I will clarify exactly now with expenses. Now, expenses, it seems to be that this go inside, but intuitively should be better in the other direction. Yeah, in this sense, this direction is negative. I mean, positive expenses is out in this sense. But very often we consider all signal directly inside. And then, of course, depending of the nature, we say negative or positive. Deposit in this notation is positive. Expenses in this notation is negative because got out. But believe me, sometimes we put conventionally all rows inside the direction. No? Liability makes sense because the liability expenses is clear. No? They should be out intuitively. But in system theory, very often we orient the system with this convention inside. Orient, the word orientation has also another meaning. I will clarify in a few minutes. Look at the L of T, liability, no? Capital over time. No? Everything is over time. Deposit is over time. D of T is over time. We will see that in the bank, time has a different meaning with respect to what we have seen until now. Hysteresis, what you have seen. Some technical systems, because in the bank, the time is the discretized time. I mean, I don't receive interest each microsecond, each nanosecond, or let me say, continuously, better to say. I will receive interest, I don't know, each 3 months, it depends of the country. Probably depends what this bank account is, could be each day. I don't know, I'm not expert about that. But anyway, we can understand that the dynamics, now we speak about interesting word. The dynamics is sampled, is difficult word, or the dynamics is, let me say, the dynamics is represented not continuously. Difficult concept now. As I told you last time, each day we have a change, for instance. At least it could be that now, for instance, the bancomat is updated online directly, but many years ago, you can see the deposit of the withdraw many years ago, yeah. Not directly, but the day after, because will be updated during the night. I remember when I was young, but anyway, now it could be that it works. I didn't care about it. Continuous time, discrete time is clear what I intend. You remember last time I tried to graph a variable discrete and a variable continuous. The variable discrete is a variable stepwise continuous. I will come back now with the yeah. The ability is, let me say, intuitively correctly oriented, because the liability is the money which belongs to me, but it's in the bank. This means this is really the kernel of the bank, because this system here, if I write house, my house, is not a dynamical system, because I can deposit, I can withdraw, but in this case, I don't have interest because nobody pays for me for the money which I am at home. The liability is exactly the money which belongs to me, but they are at home. It is a big difference because if, excuse me, they are in the bank. They are in the bank because the money is, or the money which is in the bank has the advantage that I can receive interest. This means the system updated itself. This is the concept of the dynamics. Otherwise, if I put money in my wallet today, if I don't put a different, another sense, or if I don't withdraw, if I don't spend something, it's the same. In the bank, is different. Okay, let me go ahead a little bit faster here. let me flesh out here this element as last time. Very important liability, which I already calculated, dollars or euros, I do not what. Very important here, the input is dollars per time. This parameter here, beta multiply IL, I would like to consider all together because we are not, the multiplication between beta IL, we are not expert, me too, in bank systems, but if you want to go in depth on this, we can conceive in the project. As I told you, we did 2 or 3 papers in conference. One of them received also, I showed you last time, received an award as the best paper. Exactly on this topic, we improved in the sense we enhanced the model. For the lecture is already complex this, but in the project we have time to conceive and to extend, to enhance the model. Anyway, today beta multiply IL is the interest which I receive in the bank. Now we will clarify a little bit better. In fact, if you think at this dynamics here, we have money over time equals money over time, because beta multiply IL, if you look here, it's a shame I didn't put it, but in any case, it's written here, is the interest on deposit. It is a wrong English. That the bank liabilities pay by the bank, totally wrong in the sentence, but it's the interest which the bank pays for us. I have to correct, excuse me. And this factor here is intuitive to understand, is the expenses. I mean, you remember probably if you have an account in the bank, you have a netto and the other, I will not expect, brutto? Gross, no? It means gross. This is the concept. Basically, the gross is IL and the netto is beta multiply IL. This is just to, and beta multiply IL, the unit of this is time up to -1. I don't know if it's clear. This is time up to -1 equals time up to -1, and U of t is clear. Excuse me, dollars, L of t is dollars, multiply time up to -1, like here. No? This is dollars, this part here, multiply time up to -1 is clear. And also this one, this from the unit point of view is okay. This equation here is quite complicated, but isn't a differential equation. Do you know a little bit the differential equation? A little bit from math 1, math 2, you know. Differential equation? You didn't hear about that? This means, I don't have time to repeat everything in differential equation, but anyway, look. The changes of the liability, my money which I have in the bank, changes as in a function. This means the changes equal my capital what I have, my money what I have, multiply what the bank give me, plus what I do. Just roughly speaking, just colloquially now. The changes of my monies in the bank equals the money multiply, let me say the netto interest, plus what I do. I can deposit, I can withdraw. Let me go ahead so I can clarify better this, because in the bank it's extremely difficult, this form here. Why that is difficult? Because the bank is the discrete system. In this form here, the bank is described in a continuous system. Or the model, better to say, is not exactly it's not exactly clear what is this equation here. Let me now explain this equation here, which came from some assumptions, and this reflects better the dynamics of the bank. It's clear that the dynamic of the bank is the dynamic we change not continuously. Could have each 3 months, could have the dynamics can change each day, but not continuously. Continuous variable, stepwise continuous, Should I draw? Yeah, should I draw? And then I try to clarify again this slide here, which is fundamental, really, to understand a little bit this dynamics. We have two kinds of dynamics, or we have many kinds, but in this course we will see we see two kinds of dynamics because we have also hybrid dynamics. But let me go ahead with this. One is continuous dynamics, physical system and the movement of my head. You don't see something like that. This should represent not a continuous dynamic. No? Understand what I intend. The movement which is we perceive in a movement stepwise constant. No? Even though the new physical theory says that the reality is not continuous. If you think about quantum, but I'm not expert. No? But anyway, what do you see? Is the movement which is continuous. Now, let me see. In math, we have seen something like that. The function of t starting from t equals 0 is going there. No? Now, this is a continuous function. We have also a definition, but let me go ahead quickly. This is a stepwise continuous function. To be precise, I don't know if we can understand what I intend. Let me do with this. This means from 0 to t1, I will consider this. From t1 to t2, I will consider this blue constant line, and so on. The difference is clear. The difference is clear because we can consider the blue stepwise constant function as an approximation of the continuous. But some system work let me say directly in continuous. They are not approximated with this. I mean, in the microcontroller, every phenomena is approximated by stepwise constant function because the computer works with digital system, with discretized signal, and so on. Now, and a bank system works exactly so, because I will update my variable liability not continuously, not in this form, but I don't know, each 3 months or each month, I will have a change in my account, not continuously, but at this time. And then at this time, until 0 and t1, I will remain constant. I don't see any changement in liability. Let me clarify now we can represent such kind of system. Let me share. Yeah. Look at this position here. I will approximate the derivative, a continuous derivative, in this form here, L of k minus L of k minus 1. Here, try to imagine that inside the parentheses, we have it multiply ts, k multiply ts. I didn't put because typically we don't put, because it's irrelevant, ts here. Because nevertheless, k multiply ts, I can call with another variable. But in any case, is the variable at time k minus the variable k minus 1 divided ts. What is this? If this function here is the liability, for instance, is this value here minus this value here, divided the difference. This is the derivative. the approximation of the derivative. And this the name of this approximation is forward-Euler. How many approximations we have? Many. I will present here just one. I will sketch out another one, but anyway, this is really a complex topic, but this is enough for us to introduce the most important, the most used, which is forward-Euler. Now, the difference, the most important thing, it seems strange, but it's these two elements here, which states the present. Look, L of t, the present liability, is L of k minus 1, everything multiplied by Ts. Ts I don't put inside. Also here, U of t is equal U of k minus 1 multiplied Ts. This means the approximation of the derivative is an approximation forward. Why that? Because I am assuming that I know the future of my liability, the future minus the present, divided, let me say, tomorrow minus today, divided 1 day. This is the approximation of the derivative. Now, this simple time is the difference in time between the liability in this case, but also could be any other variable. Look, if I now plug in these three positions in this equation here, it's easy to see that I will obtain this. Too difficult to see? If I plug in, Jan, if I plug in, instead of the derivative of L with respect to the time, if I plug in here, this expression here, we'll have this one. Just to substitute. And if I plug in now, instead of L of t, this L of k minus 1, from here I will have this one. Instead of U of t, I will plug in U of k minus 1, I have this. Easy. Just to copy. Let me say, plug in means copy now. Please pay attention. This is the actual value. No, makes sense. L of t. No. Now, this expression here, this again, I repeat it for you, the hypothesis. This is forward Euler, the name of this, let me say, hypothesis of a position. Now, I repeated this for you. It's the same as we had before, no? We can see. In order to explain better this expression here, which is the discrete dynamics of my liability. Look, from here to here is clear, I think. Is this enough to multiply left and right by Ts, right? If I multiply this expression by Ts, I will cancel Ts. And Ts will be here and will be here. And math in gymnasium or math 1 is not clear. Should I do on the lateral camera? Is better? Okay, no problem. This is clear, no? Lk minus Lk minus 1 divided Ts equal beta IL multiply L of k minus 1 plus U of k minus 1. That's, I clarified it. Just plug it in. Don't think about it. This is, I define this transformation from continuous to discrete, and then you plug in and you have this. Now, if I multiply by Ts this part and this part, I didn't change anything. Remember in high school? This means I will have Lk minus Lk minus 1 because I can cancel. And here I will have exactly what I told you before. Beta IL multiply Ts. For instance, you can also represent in a different form. Now it's clear, no? From here to here is clear. And then I will bring this other side. And this is exactly the equation which I try to explain before, but too quickly. Now, here, how I can read this? This is easy now to be interpreted. because this really reflects the reality of the bank. Again, reflect the reality of the bank because the bank works stepwise in stepwise constant form. Meaning, the money which I have tomorrow, or better to say today, the money which I have today is equal to the money which I have yesterday. What do you prefer, today or tomorrow? Before told you about tomorrow. Do you remember I told you forward means today is LK minus 1 and tomorrow is LK. Or the better to say, today is K minus 1, tomorrow is K. From the model point of view, no difference. It's just a way to, because we can predict in any case. What do you prefer? Today. Okay, this is today. And this is yesterday. This means what I have today, because only what I have today in the bank is equal what I had yesterday. Liability is clear what is it. Plus what I received from interest, what I sign in my contract, B beta multiply IL, do you remember netto gross? Multiply the time, 1 day, assuming that I have a contract with 1 day. Otherwise, tomorrow and yesterday doesn't make more sense. We have to say 3 months ago and today. But of course, with respect to what I had yesterday. I mean, if I have $1 million, I will receive more money as an interest. Therefore, this makes full sense. The contract, which is included, so the time, if you want, and the money. I don't know if it's clear. If I yesterday have a lot of money, I will receive an interest proportional to this money. Proportional. The key word is proportional, the product. Now it's clear, more clear as before, because you have money equal money, plus, please pay attention here, this was dollars divided time. I multiply by time is again money. You remember this? And what is this money here? What I did in this 24 hours. If TS is 1 day. Now you can understand the money, the model a little bit, or not. We can understand better than this differential equation because the bank works exactly so. With my wording, I try to explain today, tomorrow, a little bit confusing, but I think this is clear. It is difficult now. Very important now. It's also in the slide. Look at what I do. Do you like this? You don't like, okay, it doesn't matter. Did you, I don't remember if I showed you the paper with which we received the award. I didn't show you. With a student of this course, we received an award in a conference. We advanced. I didn't show you last time. Should I do it to motivate you to work? Okay, it doesn't matter. Let me go ahead. At the end of the lecture. Look, why I put in this form here. With this form here, which is exactly the same, this, no? It's no difference. It's just an we can really better understand why it's worthwhile to put money in the bank and when it's worthwhile. In your opinion, from this system, let me consider this zero. Huh? I don't do anything. This is the concept. If I don't do anything, why have to put money in the bank? Okay, it's more safe, but forget this. I have at home, I have it in a way to put. When it's worthwhile to put money in the bank, we can see from here. If this element here is positive. If this element here, to be exactly precise, I will calculate now. When I will increase my my money. I will increase my money, as I told you, if this here is positive. Or to be mathematically correct, should be something like that. But of course, this part here is a little bit strange in the bank. I don't know if it's clear. This here, if you consider this part here, we can understand well that 1 less than 1 plus BIL TS implies that this here larger than 0, right? If you consider this, this means that BIL TS less than -2. That's a little bit strange, no? Because we have seen that beta multiply IL must be positive. Do you remember in my assumption? This means what we needed as well. This is important because we say that this system here, the bank system, is unstable system. This means if I start with $1, if I don't do anything, and this factor here is positive, I will increase my money. Definitely. I don't lose money. But of course, if this is negative, it's not the case. I told you before, we cannot say that I will increase the money. I will increase the money nevertheless. Also in this case here, but it's extremely strange because I will have a positive money, negative money. It's just a mathematical, should I clarify this a little bit better? Here is clear. And this is what we need. This here is a little bit a mathematical calculation, which allows to say that, for instance, I show you an example in order to, but it's not useful for us because does not represent the bank. I mean, look at this. What happens in your opinion if I have this? Considering at time 0, we have $1. Time 0 means k equal 1, yeah? This means at time 0, I have $1. What happens here? No? What happens at time 1 in your opinion? -2, which multiply. Did you agree? Because what is this? L of 1 equals -2 L of 0. This means this is L of 0. Did you agree? Excuse me. Do you agree? Look at this. What happens here? Excuse me. No, it's okay. It's okay. What happens is this one. It's clear that cannot be in a practical. I mean, nobody will sign the contract with this. In fact, please consider just this case here. Let me conclude this part here, and then we will introduce another concept extremely important. This I already a little bit clarify, also a little bit better because I add some consideration, but also from here, now we can understand that I will increase just if this part is positive. Probably could be also better interpreted from here. The rest is just a mathematics. If this is positive, I will increase. If it is negative, I will decrease. Therefore, don't sign a contract if it's negative, but it does not exist. Here, just to flesh out, just to show you that there is also a different way to build the model. We can see, I don't want to go in depth on this. Assuming this position in which what changes just the definition of the present. Before with forward Euler, we have the present equals k minus 1. Here, the present equals k. This means I will approximate the derivative back because I have the present here minus the past. Don't care about that, but just look, if I plug in, we have a totally different model. The totally different model. What is the correct one? No one. Because you remember at the beginning, I told you we are not to look for something correct. We are looking for something valid. Both are valid. No one is correct. When we use one, when you use another one, is difficult not, but in this course, I don't have time to tell you about that. But in the project could be that we can go ahead together, giving some literature and give you some indications. Could be also nice to compare the two models in the context of some controllers. Now, what I would like to do today, this is the sum up both. And here we have also, if you want to compare both, I think here should be plus. Yeah, should be plus. Excuse me for the error. Should be, this is in LaTeX, it's built in LaTeX. This should be plus. No, it's correct, it's correct. Let me see. Excuse me. Let me calculate because it's correct, it's correct. Yeah. At this moment, I don't want to go ahead with this. The goal to show you that there is also many orders, not only these two. This is in the context of Euler. You have backward and forward, or forward and backward, with two different assumptions on the present, and then we have two different models. Just the messages, which is the best, depends on the goal which we want to do. At this moment, there's too many information for you, but the information, we can build a different model with different goal. What is correct? Nobody is correct. No one is correct. But both can be valid, depend on what we want to do with the goal, with this model. At this moment, let me remain on forward. Here, again, both assumptions, again, both model. Just a remark. Look, they are totally different, but we can understand, for instance, that this model here, if we want to do a prediction, it could be that is more suitable because react directly on the input of today. But let me go ahead without explaining this. But think about that no one is better than the other one. Depends what you want to do. We can see a little bit together with the project if you want to go ahead with this. Now, in the bank, we have another state. And at least in this context here, in this easy model or straightforward model. The other state is the assets. Look at this. I try to define here at the beginning the assets. This is the money belong to the bank this time. You remember the liability belong to me is in the bank. Here's a little bit different. It's let me say the contrary. You remember, liability, money belong to me, but I lent to the bank, and I receive interest, clear. Here is exactly the contrary. It's the money which belongs to the bank, but the bank lent to borrow. I come to the bank and say, I need a credit. This is exactly the asset. It's a little bit more complicated. I heard that also other titles belong to assets, but remain on this. Remain on this. Probably you are expert in economy better than me. I hope no mistakes. But anyway, remain with this. But the asset is it's more larger as a concept, not only this. In fact, no. Okay. Look, the equation which characterizing continuous the dynamics of the asset. Here I forgot before to put the initial value of the liability. But anyway, you know that in the example which I explained with the lateral camera, I put it. I mean, this condition here must be given also for the liability. Of course, you can also open an account also with money zero, but if you don't put money, we cannot start with the dynamics. Here is quite similar. You can put zero, you can put any value, but anyway, it should be given. Look at the dynamics here. The dynamics is a little bit different. It's a little bit different with respect to the dynamic of the liability because lambda is a parameter which is extremely interesting because typically it's not so easy to be identified. It's a parameter which you can see here. We cannot predict exactly how many borrowers will default. How many borrowers partially default. This means in our publications, in our project, we estimate somehow this lambda here. Depends in any case, this is very important to understand, on the money, on the deposit. I mean, liability and assets, they are connected. It's connected here, at least from this model here, by U, because U is the same input or the deposit which I have in the liability. Now we will see a little bit in the model, a little bit more complex, but we can justify a little bit better, probably using the more complete model. You can justify a little bit better the concept of the assets. Very important here is to understand that this U is the same U because the assets changes also is a function of U. Let me clarify a little bit better. At the beginning, probably without U. I don't know if you remember the solution of this differential equation in math. Did you do math? No. I show you what I did. Just to colloquially understand this A of t. The dynamics of A of t starting from, not from zero, for, I don't know, 100. Is a dynamic which is let me share. Okay, I think I don't have to need to do anything. Now it's blocked. No. I don't know a little bit if you remember this. If the bank started with an asset 100, and without deposit and lend money, of course, the asset, the money in the bank is going to zero. This is the idea of this model here. Of course, if then we put money, of course, this is a little bit different because the solution depends on the u of t, as you learn in math, but at this moment, just to understand without u. But of course, now this model here is just an artificial model because if I put money in the bank, I have a liability which interact with A. In fact, the full model, here is a little bit the clarification which I already told you. The full model continuous full model consists of two equations in continuous at this moment. The full model consists of these two equations in which we can see that this model is exactly what I told you until now in the assets. And here, the assets is going to increase, let me say, increase the dynamic or to modify the dynamics of the liability. Let me see. Here, nevertheless, now I see an error. Yeah, the error is this. I changed the design. If I remember well, this should be plus because it was plus. Otherwise, it doesn't make sense. Here must be minus. I suppose that I'm considering the lecture which is not updated. Let me see. Let me confirm. In fact, we can see here, which cannot reflect this. Again, here we have an error. It's inverted. Here is plus. Here is minus. Makes sense. I clarify why it makes sense. It was plus before because otherwise that doesn't make sense. I mean, I have to increase my liability. The change of the liability must be increased with my liability. Why is minus? Because from the bank point of view, if the bank lent money, the liability which is in the bank, which is the money which is in the bank, decreases. This means this equation can be considered correct. But here we have a minus, here we have a plus. Excuse me for the error. I will clarify here. I put it again here. And now please pay attention here. Here is put correctly the sign. I corrected the sign from here to here. It's clear what I did from this to here, except for the sign which I made mistakes. I mean, here is correct. It's clear from this information to this information. I will clarify. Again, here is minus, here is plus. Excuse me for the error. Here is minus, here is plus. But here at the end is correct. Excuse me for it's in LaTeX. Sometimes it's not so easy to write in LaTeX. LaTeX, I clarified last time what LaTeX is. Because you write, but you don't see directly what is the results. Even though I am an expert, but sometimes I am writing extremely fast, even though this is not the final version of the lecture, because I remember I corrected, but I didn't find quickly. Nevertheless, let me clarify this equation. I copy and then I come to you. I copy with the correct sign. Look, I copy for you. I correct it. This is enough to put minus here. No? Did you agree? Excuse me for the error. Don't trust the professor who doesn't make error. Who don't make error, believe. If I put a minus here, here you can preserve this sign inside. Look, this form here is an algebraic form which you know from math or from high school. What I am trying to do is to perform the same model using another language, the language of the matrix and vector. I can vectorialize this information in this form. This means these two information I put in a vector. You know in a vector what is? In a vector, what is in a vector? Is in a table with elements. Could be a column vector, like in this sense, could be a row vector. Yeah, table is more in a matrix, but then the vector is in a matrix. Matrix, you know what is? A table, no? Also, this is in a table. Just colloquially, but it's not bad, this. Equal what? Look what I'm doing. If you look at this part of, probably for engineers, it's trivial what I'm saying. It's boring, no? Because you know already, probably. Okay, it doesn't matter. Because not all are engineers here, no? Look what is the idea. The idea, if I look here, I see that this part here consists of A, L, and U. This means the variation of my L and A, the variation of my L, A in continuous bond, then at this point, then we will do discrete. I can consider S here as a function of A and L and U. Again, the money which I have in the bank, depends of the assets. It depends on my liability. Why depends on all the assets? Because if the bank lent a lot of money, I cannot withdraw the money. This should never happen, but it could happen. Bankrot. Yeah, because we can see that now we will clarify better. The money belongs to me, but it's in the bank. There is also a risk that I will never have back the money when the assets is too high and they don't have money in the bank. I try with colloquially understand with words to explain what is the dynamics. I think the bank is a good example to start, because when next week we will see the Lotka Volterra, this is really heavy. I don't know it's heavy, but anyway, this is easy to see the reaction. And it is clear that also in the bank is not save the money. From this model we can see, and believe me, we can consider some project in this context here. We did. Of course, in the lecture I cannot tell a lot because we don't have time. I have to consider all the topics. This means what I have to write here to obtain the dependence of the variation of my liability assets, in your opinion. You remember the rule row multiply column? You remember? We code it in a rule which say when I do the product between a matrix and a vector, or between two matrices, assuming that is possible, I do row multiply column. Do you remember this? This element multiply this element multiply this. This means if you look here, it's clear that this element will be beta multiply IL, and it's clear that this element will be beta minus beta multiply IA, because this element multiply this, I will get this with minus minus plus. And this element multiply this, I will get this element here with the minus. I don't know if it's clear. If you remember the rule row multiply column. Plus, I have to consider also the deposit. What I have the deposits? One. That is more this one. Now here is easy because I have a zero, because I don't have the dependence of the liability. In this model, please pay attention. In a saved bank, consider to lend money in accordance with the money what they have. This means this is a little bit in a simplification. Of course, we have also here something which depends on the liability, because if I don't have money, I cannot lend. What I have to write here? Very good. And here one. Now, I clarified these languages, a new language. Why this language is important? Because the computer works very well with matrix and vector, or the vectors, with matrices and vectors. Okay, here is the initial data, capital in the sense liability assets, both are capital. Look now. What I try to do is to discretize both. The first one I already discretized. I hope no mistakes. Yeah, I see mistakes. It's plus. No. It's correct because it's the parenthesis here. It's the parenthesis here. As I told you, I corrected also in my slide, with the lateral camera. I put just a minus here. I don't know if it's visible. It's correct. Exactly what I did with the lateral camera. I put a minus here. Now it's correct. Should I clarify the discretization, or is understandable from the discretization which I did before without the assets? Without the asset is exactly what I did before. I don't know if it's visible. Without this variable is exactly the equation which I did before. Gian, should I calculate? No. It's clear, no? Because the asset is calculated at k minus 1 in accordance to forward. Basically, I put inside, I show you, because so we can. This was. It's exactly the same, but now I will have add just minus beta multiply a capitalized k minus 1. No? Because I put the forward Euler in a of t. The discretization of this equation here, of this equation is trivial because I have a of k minus a of k minus 1 divided ts, if you consider exactly discretization, equals minus lambda a of k minus 1 plus u of k minus 1. And then what I did is I multiply by the s left and right. And then I put this minus a of k minus 1, which was on the left part, on the right part. Should I do? It's better. Okay. Think about this equation here now in continuous. Let me write. Right? Now, forward Euler. If you look at the definition, but it's easy to remember. I plug it in instead of the derivative this. And the actual value in accordance to the forward is k minus 1. If I do backward, is k. Totally different model, totally different approach. Don't want to go in depth. Now, from here, if you multiply left and right by ts, I will obtain almost the solution. The sample time, 1 day, 3 months, 5 months, 10 years. It depends on the contract we do sign. And then change also probably beta on IL. If you vinculate the money 100 here, could be that you learn a lot of money, but you cannot probably receive back. Anyway, this is the contra problem. I try colloquially with a stupid example to show you how could represent a real situation. Of course, here in the lecture, if I present the real situation extremely heavy, well, yeah, this means concept. In the project, we can go really in depth. Now let me write. I would like to go ahead 50 minutes. It's okay? 15, 10, 5, close. Right, let me close the slides. No? And then next week, should be nice if I will be able to simulate a little bit, but we can simulate the Lotka Volterra. We will see COVID situation, population dynamics, bacteriological dynamics. This is a little bit more complicated, even though we can really realize an extremely complicated economic model. But to start, otherwise, already I realize this is already complicated. No? Okay, now if I multiply by TS, let me put this in front because it's more typical. Hmm? Now we can see exactly. And then should be visible. Exactly what I told you. Let me see if I can comment because we are almost at the end. I think I mm. And here I put the two discretized equation in the matrix form. Now I think we can understand this. No? We can understand because we have this element here vectorialized here, and then tomorrow or today, if you want, as a function of, if this is today and a function of yesterday, and here we have to build through the matrix the same information which I have here in order to work with the computer, let me say quickly, and here TS, which multiply UK minus 1. Here we have a disturbance which I didn't put now, but we can put a disturbance in the sense expenses. Another vector could be here, but this moment I didn't put, plus again TS uh, 0, because typically the expenses is related to my money, which belong to me, is in the bank, which multiply d of k minus 1. D of k minus 1 is in a vector, is in a money, which I have to pay each TS. To recap a little bit, here I would like to repeat a little bit. This is too difficult. Sometimes the student ask me again the background here. Each 3 months, I will update my liability in accordance with the contract which is related to 3 months. In this case, TS is 3 months. And here means that I will update my account, what I did in deposit or withdrawal in 3 months. The same if I have here an expenses, TS, which multiply D of K minus 1. D of K minus 1 is like you, but I cannot manipulate really D as U because D sometimes is something unexpected. Okay, if I have to uh, to pay rent for my apartment. In this case, I can know in advance. I can know exactly. But sometimes I have some expenses which I cannot know in advance. U of k minus one typically is the control input, which I can predict or I can plan to achieve the liability in my bank $1 million. I don't know when, but I can fix with some controllers. Okay, just a few words. Do we have time to simulate? We have time to simulate? We don't have time to simulate. But I will do next week before starting with the load counter. We already introduced one important concept in two forms. We say that liability assets represent the state variables of this bank system. What is the state variables? The state variables, what are the state variables? Are variables which represent the energy of the system. Now, about energy, let me say we were a bit to think about kinetic energy, potential energy, electromagnetic energy. This is exactly let me say, the physical energy. But in system theory, also in this course, we can introduce a more wide concept of energy, or if you want, a pseudo energy. Money, in the sense of liability, not money itself, because I need the dynamics. Money are energy, in a sense, but in the bank, not at all, because of the dynamics. It's energy somehow, or the pseudo energy, liability. Liability is money, but money is not liability. No? Depends where is this money. And my wallet is not energy. It seems to be energy, but it's not. Assets, the same. Everything which change over time, dynamically means within a feedback, we call state variables. I will come back on this. What is the meaning change over time dynamically? This. Or if you like, discrete form. Here, we can see that today, even though I don't do anything, the money is different respect to yesterday. This means state variable. If I don't do anything, the money in my wallet remain the same. This means this money don't represent the state variable. Because the state variable is something which is moving itself.
So that kind of the flow of system.
If you like to call so, it's okay. Is a variable which changes inside the dynamical system. And dynamics is exactly this. Something today, which is in a function of something, of the same thing, let me say in a variable of today, better to say, which is in a function of the same variable of yesterday. It doesn't matter if it's going to zero or it's going to growing up. Assets is going to zero if I don't do anything. But this is really an extremely easy bank model. We can improve a lot. Because if you look here, if you don't have the bank, if you don't have this input in accordance to this equation here, it could be that they don't have money to give back. I'm not expert in economy, but we also consider a different model And also, we don't, here in this lecture, we didn't consider any inflection rate or inflection parameter. Anyway, this is already extremely complicated. Okay, I think next week we will restart a little bit. I will correct it. I have to put just one minus, no? We have to see. We correct a little bit this. I will re-upload, but I told you where it's not error because at the end I corrected. I didn't put here a disturbance. We will see in the simulation the disturbance is extremely easy because the disturbance involves the liability. No? Because if I pay the money, I'm not sure. At least in this model could be considered just as a disturbance which influences just the liability, I think. I would like to say I'm not expert, but I will check and then because I took this from a book, we will see. Yeah, next week we will in any case we'll simulate, and then we will start with another dynamics. And the dynamics of next week is the population dynamic, infected people, susceptible people who could be infected, in the context of Lotka Volterra, in the context of prey-predator model. The infected people try to infect more people. And we will see a relatively easy structure, but not so easy nevertheless, without latency, without immunity a little bit, yes, but not so complex. I will consider the immunity people in our model is the people, I mean, in the model, I don't remember which model I can present next week, but the people can be reinfected. If I remember well, the model which I will present in this course, I have many models. What we cannot be reinfected is the people who die. Yeah, I included the recovered. In the example which I will present, I include the recovered in the people who died. Recovered and died together, because when we died, we recovered. I mean, we cannot be reinfected. We assume that, but I don't know if it's in virology they agree this. Yeah, so. But once infected, we cannot be reinfected in the model which I will present. Otherwise, it's extremely complex. Again, no more dynamics. Okay, if I have questions, otherwise next week we will, the program is all. I told you already what I did next week. Then it could be that I will be able to show a little bit the control. I'm not sure because I would like to introduce also Simulink. And at the end of the course, I will reconsider the problem of the identification, parametric identification of the parameter. Which one? Today, the parameter was, for instance, lambda, or it could be, lambda is one of them, or the interest typically is fixed. Lambda, we are saying, in this kind of model, because you remember this was default, the percentile of default. This is difficult to have an value and should be identified. Okay, let me close the lecture. Thank you for your attention. Excuse me again for being late, but of course I'm not able to be precise.